Hello everyone, welcome to International Junior Science Olympiad 2010 Physics Solutions. Given that universal gravitational constant G equal to 6.7 into 10 power minus 11 Newton meter square per kg square and the mass m of the earth is 6.0 into 10 power 24 kg, find the speed of a satellite that is fixed permanently to focus on the city of Abuja for broadcast of the 2010 Ijso competition. Since the satellite is fixed to permanently focus on one location, it is a geostationary satellite. Height of a geostationary satellite is 36,000 km approximately. Radius of the orbit small r equal to r plus h, which is 6,400 plus 36,000, 4.24 into 10 power 7 meter. Orbital speed of the satellite V0 equal to root gm by r, that is 3.08 into 10 power 3 meter per second. The surface of a biconvex lens have radii of curvature of 0.1 meter and 0.15 meter. Given that 1 by f equal to n minus 1 of 1 by r1 plus 1 by r2 and the refractive index of the glass is 1.5, find the power of the lens correct to the two significant figures. Radius of curvature of the first surface r1 equal to 0.1 meter, radius of curvature of the second surface r2 equal to 0.15 meter. Refractive index of glass is 1.5. Optical power of the lens P equal to 1 by f, that is n minus 1 of 1 by r1 plus 1 by r2. So P equal to 1.5 minus 1 of 1 by 0.1 plus 1 by 0.15, which is 8.3 diopter. The Doppler Principle refers to a difference in frequency observed due to the relative motion of observer and a moving source. Speed limit violators are usually monitored by the use of a radar gun which releases microwaves on the moving vehicle in short bursts. By applying the Doppler Principle, the difference delta F between the frequency of the microwave emitted by the radar gun and the reflected by the moving vehicle is obtained. The velocity v of the vehicle is then determined. If delta F is 2667 Hz and the frequency of the microwave is 1 into 10 power 10 Hz, obtain the speed of the car. Speed of the microwaves in air is 3 into 10 power 8 meter per second. Let the speed of the car be v meter per second. Actual frequency of the microwaves is 1.0 into 10 power 10 Hz. Difference in frequency detected is 2667 Hz. Applying Doppler principle for electromagnetic waves, delta F by F equal to 2v by c for a moving source. So V equal to delta F by F into C by 2, which comes out to be 40 meter per second. Solar radiation reaches the Earth's atmosphere at a rate of 1353 watt per meter square. If 36% of this radiation is reflected back into the space, 18% is absorbed by the Earth's atmosphere. The radiant emittance given by sigma T power 4, where sigma is Stephen Boltzmann's constant and T is absolute temperature, what maximum temperature would an isolated black body on the Earth's surface be expected to attain? Take sigma equal to 5.67 into 10 power minus 8 watt per meter square Kelvin power 4. Intensity of solar radiation reaching the Earth I equal to 1353 watt per meter square. 36% is reflected back and 18% is absorbed by the Earth's atmosphere. Percentage radiation incident on the black body is 100 minus 36 plus 18, that is 46%. Applying Stephen Boltzmann's law, I equal to sigma T power 4, 0.46 into 1353 equal to 5.67 into 10 power minus 8 into T power 4, which gives us T equal to 323.67 Kelvin, that is 50.7 degrees centigrade. A body of mass m resting on a smooth inclined plane at an angle theta to the horizontal is connected to a mass M over a smooth pulley as shown in figure. Find the velocity v of the object of mass m when it has moved through a distance b up the plane. For the hanging block, we can write mg minus t equal to ma. For the block on the inclined plane, we can write t minus mg sin theta equal to ma. 1 plus 2 will give mg minus mg sin theta equal to m plus m into a, which gives a equal to g times capital M minus small m sin theta by capital M plus small m. Velocity of the block after traveling a distance b, v square minus u square equal to 2as, v square minus 0 equal to 2b into g times m minus m sin theta by m plus m, which gives v equal to root 2gb of m minus m sin theta by capital M plus small m. In using an axe to split firewood, the following energy forms are involved: chemical energy, mechanical potential energy of the axe, chemical energy of wood, heat energy, sound energy and kinetic energy of the wood fragments, mechanical kinetic energy of the axe. Which is the most likely sequence of the energy exchanges? Here we need to split firewood with an axe. The sequence of energy exchanges is chemical energy, mechanical potential energy of the axe, mechanical kinetic energy of the axe, chemical energy of the wood, heat energy, sound energy and kinetic energy of wood fragments. A jet of water traveling at a velocity of 20 meters per second hits a wall normally. Calculate the pressure on the wall if the water does not bounce back. Density of water is 1.0 into 10 power 3 kg per meter cube. Velocity of the water jet V equal to 20 meters per second. Density of water is 1.0 into 10 power 3 kg per meter cube. Force exerted by the flowing water F equal to A rho V square. So the pressure exerted by the water jet P equal to F by A, that is rho V square, which is 4 into 10 power 5 Pascal. The rate of heat conduction is proportional to cross-sectional area and temperature gradient, that is temperature difference per unit length. On a typical day during the World Cup tournament in South Africa, the air in a room is heated to 25 degrees centigrade while the air outside is minus 2 degrees centigrade. The area of the window of the room is 2 meters square and it is made up of crown glass with a thickness 2 mm and thermal conductivity 1 watt per meter Kelvin. What is the heat power loss through the window? Temperature difference across the window delta theta equal to 25 minus of minus 2, that is 27 degrees centigrade. Area of the window 2 meters square. Thickness of the window pane is 2 into 10 power minus 3 meter. Coefficient of thermal conductivity of the material K equal to 1 watt per meter Kelvin. Heat power loss through the window P equal to delta Q by delta T, that is Ka into delta theta by L, which comes out to be 27 kilowatt. The ratio of radii of two planets P and Q is X and the ratio of their mean densities is Y. Find the ratio of the acceleration of free fall in P to that of Q in terms of X and Y. Ratio of radii is X and ratio of densities is Y. Acceleration of free fall on a planet G equal to gm by r square. In terms of density it is 4/3 pi g r rho. So we can see G is proportional to the product of R and rho. So Gp by Gq equal to Rp by Rq into rho p by rho q, that is xy. 2 point charges Q and capital Q are separated as shown in figure. Determine the electric potential difference between points X and Y. Potential at X, Vx equal to kq by 3 minus kq by 5, that is 2kq by 15. Potential at Y, Vy equal to minus kq by 3 plus kq by 5, that is minus 2kq by 15. Potential difference between X and Y, Vxy equal to Vx minus Vy, that is 2kq by 15 minus of minus 2kq by 15, 4kq by 15, which is a 7.2 volt. Solar radiation. It is well known that fossil fuel based sources of energy are exhaustible. As such, over the years, attempts have been made to source, harness and develop other sources of energy. These alternative energy sources may include solar energy, wind energy, nuclear energy and energy from biomass, among others. The sun, which is the source of solar radiation, is a sphere of intensely hot gaseous matter with an effectively black body temperature of about 5800 Kelvin. The sun has a diameter of about 1.4 into 10 power 9 meter at a distance of about 1.5 into 10 power 11 meter from the earth. The temperature in the core of the sun has been estimated to be between 8 into 10 power 6 and 40 into 10 power 6 Kelvin. It is believed that the sun is a continuous fusion reactor in which several fusion processes occur. The fusion process usually considered most useful is a process in which 4 hydrogen nuclei combine to form a helium nucleus. The mass of the helium nucleus is less than that of the 4 hydrogen nuclei. This mass defect in the reaction appears as energy released. The energy released is given by E equal to mc square, where m is mass and c is speed of light. This energy is transported to the surface from where it is radiated into the space. Radiation reaching the Earth's surface has two components, direct and diffuse. Nigeria is the tropics where solar energy is available in abundance. Therefore, if properly harnessed, solar energy could serve as the much desired alternative energy source for industrial and domestic uses. There is, however, dearth of basic data on available solar radiation to enable incorporation in national planning. To this end, many measurements have been made to estimate the available solar radiation. This has also led to the establishment of models for predicting solar radiation in various locations of the country. In an experiment to determine available solar radiation in Abuja, Nigeria, a cadmium sulfide photoresistor was used. When solar radiation is incident on the photoresistor, its resistance decreases. By proper choice of resistances, in a Wheaton's bridge apparatus, the resistance R of the photoresistor can be obtained. The readings obtained are displayed in the table. The cadmium sulfide photoresistor obeys the relation SR power alpha equal to beta, where R is the photoresistance in ohms obtained from Wheaton's bridge apparatus, S is the solar radiation in watt per meter square, alpha and beta are constants. The fusion process is represented by the equation 4 times H11 gives rise to He24 plus 2 positrons and a neutrino. Given that the mass of hydrogen atom is 1.00794 U and mass of helium is 4.002602 U, and neglecting the masses of positrons and neutrino, calculate the mass defect in kilograms and the energy in joules released during the reaction. Given fusion process, 4H11 gives rise to Hu24 plus 2 positrons plus neutrino. Mass on the reactants side is 4 into 1.00794 into 1.66 into 10 power minus 27, that is 6.693 into 10 power minus 27 kg. Similarly, mass on the product side 4.002602 into 1.66 into 10 power minus 27, so it is 6.644 into 10 power minus 27 kg. Mass defect delta M equal to mass on reactants side minus mass on product side, which is 0.049 into 10 power minus 27 kg. So the energy released E equal to delta M into C square, which is 4.41 into 10 power minus 12 joule. The solar constant is the amount of incoming solar radiation per unit area per unit time just before entering the atmosphere in a plane perpendicular to the rays. Assuming that Stephen Boltzmann's constant is 5.7 into 10 power minus 8 watt per meter square Kelvin power 4, estimate the value of solar constant. Solar constant is defined as the solar energy received on Earth's surface per unit area per unit time. Intensity of solar radiation Is equal to sigma T power 4, 5.7 into 10 power minus 8 into 5800 whole power 4, which is 6.45 into 10 power 7 watt per meter square. Power of solar radiation Ps equal to Is into surface area, that is 4 pi r square. Power received on the earth per unit surface area S equal to Ps by A, that is Is into 4 pi r square by 4 pi capital R square, where capital R is the mean distance from earth to sun. Effectively, solar constant S equal to Is into small r by capital R whole square, which comes out to be 1404.67 watt per meter square. What is the approximate time in minutes it takes radiation from the sun to reach the earth's surface? Distance of the earth from the sun d equal to 1.5 into 10 power 11 meter. Speed of light in vacuum c equal to 3 into 10 power 8 meter per second. Time taken by solar radiation to reach the earth T equal to d by c, 1.5 into 10 power 11 by 3 into 10 power 8, that is 500 seconds, which is 8.34 minutes. Suppose the energy of one photon of solar radiation is 3.87 into 10 power minus 19 joule. Calculate the wavelength of this radiation. Energy of each photon E equal to 3.87 into 10 power minus 19 joule, that is 3.87 into 10 power minus 19 by 1.6 into 10 power minus 19 electron volt, that is 2.42 electron volt. Energy of a photon E equal to hc by lambda. Here hc is 1240 electron volt nanometer. So 2.42 equal to 1240 by lambda, that is lambda equal to 512.4 nanometer. Rewrite equation 1 in logarithmic form that will enable you to determine the constants alpha and beta from a graph of log 10 S versus log 10 R. Go through the table for some time. The cadmium sulfide photoresistor obeys the relation SR power alpha equal to beta. Applying log on both sides, log 10 S plus alpha log 10 R equal to log 10 beta, which can be rearranged as log 10 S equal to minus alpha log 10 R plus log 10 beta, which is in the form of y equal to minus mx plus c, a straight line with a negative slope and positive y-intercept. Use the equation obtained in question 1.5 and data provided in table 1 to plot a linear graph. Write the equation of the graph plotted, deduce the values of alpha and beta. Log 10 S equal to minus alpha log 10 R plus log 10 beta. Equation of the graph is log 10 S equal to minus 1.3203 log 10 R plus 3.5773. From the above equation, we can write alpha equal to 1.3203 and beta equal to 3778. I am leaving the graph for the students as an exercise.